Hello, I am Emilia Ciureca from Fraunhofer IESE, a PhD candidate in the area of building trust in ecosystems and ecosystem components. And today I will present the advancements of the reference architecture for trust-based digital ecosystems. More specifically, we will discuss about goals in trust-based digital ecosystems. More and more products around us become interconnected and they form digital ecosystems. In the future, it is expected that vehicles also will connect to each other and will form automotive smart ecosystems. When they are part of an ecosystem, autonomous vehicles can negotiate different tactical goals and plan routes, decide to drive together in vehicle platoons, and in this way they are able to satisfy higher level strategic goals like saving of fuel consumption. Imagine a scenario when at the entry point on a highway, vehicles receive smart software agents that enable them to form vehicle platoons. When they drive in platoons, due to reduced air friction and synchronized maneuvers, the vehicle can also save fuel consumption. Unlike system of systems, ecosystems consist also of actors, such as users, organizations, developers, part of an organization, and different actors may have not only collaborative goals, but competitive goals as well, and this significantly influences the dynamics within an ecosystem. Higher level strategic goals like saving fuel consumption depend on the fulfillment of lower level strategic goals like forming vehicle platoons that in turn depend on the fulfillment of operational goals of every smart agent that operates on vehicles, and the goals of smart agents could be to share context information or keep a specified speed within a platoon. For building trust in an ecosystem and ecosystem components, we use the concept of digital twin, which has been introduced by NASA in 2010 as a realistic digital representation of a flying object used in lab testing activities. Since then, the notion of digital twin has also been adopted in the emerging Industry 4.0 for representing the status of production devices and to enable forecast of change impacts. To support the formation of digital twins for digital ecosystems, last year we proposed a reference architecture which consists of three main packages. The ecosystem package centered around systems units and actors. The goal package, which contains elements related to goals, risks, and role of actors within an ecosystem. And the reputation package is where trust is computed in various verification scenarios. A digital ecosystem aggregates multiple parties which can be actors or system units. The system unit itself can be a collaborative system group, systems and system components such as hardware resources and software components. In the goal package, each party has a goal, and goals are classified in hierarchies and analyzed with regard to risk in case of deviations. The deviations are observed with regard to verification scenarios that are defined in correlation to different contractual agreements between services. The agreements are in the form of demands and guarantees. The reputation package is the one that holds the concept for computing reputation of ecosystem parties. By computing reputation, we derive a computation-based trust of an ecosystem. Runtime evidence provided by system and service execution feed into a top-down classification of goals that safeguards fulfillment of strategic goals. In a bottom-up fashion, evidence of goal deviation at the operational level can build upwards towards evidencing malicious attacks. The dynamic evaluation of goals on the second scale in terms of anti-goals enables a forensic analysis of systems deviations caused by malicious attacks, for example. The trust in an ecosystem emerges from trust of its aggregated components. In this direction, we've proposed recently two interrelated methods for building trust, also based on digital twin execution for goal evaluation. In 2019, in the paper Do Not Trust in Ecosystem, we have introduced the idea of building trust into software applications that can potentially contain malicious behavior by executing their digital twin instead. The software applications are the ones that enable the implementation of the operational goal of a system. The approach consists of a method that spans from design time to runtime and requires that the smart software agent is delivered together with its digital twins. On a system, the behavior of the smart agent is predicted at runtime by evaluating its digital twins in a simulated world, and if any malicious behavior is to be discovered, then only virtual entities would be affected and not real entities. But the human user is also an important actor of the ecosystem, and the technical trust is as good as it supports the human trust. Then what we did 1 year later in the paper Building Trust in the Untrustable, we've introduced a methodology for supporting the incremental building of trust of a human into a highly autonomous system and of a system in the behavior of a smart software agent received through download at runtime. In order to avoid misuse, which means that technology is not properly understood and is used in the wrong way, or disuse, which means that technology is not trusted and therefore not used at all, we propose a stepwise replacement of system functions with software functions. And in a process derived from a novel neurological method of building new habits, we developed a systematic process for engaging the user into monitoring the behavior of newly received system updates in form of smart software agents. The safe behavior of the smart agent is predicted through digital twin evaluation, and only when the behavior is proven safe through predictive simulation, then the behavior of the system controlled by the new software smart agent is predicted and displayed to the user. The user then monitors the actual execution of the smart agent, and if the system behavior is as expected, only after the smart software agent builds a satisfactory, proven in user reputation and a satisfiable level of human trust has been reached, then the smart software agent runs in the background without user monitoring. And all depends on dynamic goal evaluation of system and system components that is performed at different level. As a summary, innovation on the roads and in the energy domain is envisioned to be enabled through a continuous engineering practice that spans from design time to runtime. That is why we consider, besides system of systems, actors which get dynamically involved into advancing the services within these digital ecosystems. These actors on one side need to be trusted, but we also need to gain their trust with the system that we provide. Overall, the dynamics within an ecosystem becomes more and more complex, and we think that the notion of digital twin and the notion of dynamic goal evaluation can help us to compute trust in a whole ecosystem and to compute trust in each of ecosystem participants.